Well, my name is Ahmed and we are group number 10. My partner is Rasheed Al-Hazimi. We are working on a project which using machine learning techniques for predicting and visualizing COVID-19 vaccination process. So what happened is we changed our data set from the previous increment. This increment is number 3, and increment 2, which we had some issues with the data set previously. So it was changed to a new data set to complete this project. Okay, so the new data set is about the uh, uh, countries that got vaccinated, vaccinations so far. Uh, the date is until almost May 1st, so this is a new data set I got from Kaggle. So here we have different attributes. We have the total vaccinations, people vaccinated, people fully vaccinated, and the daily vaccination from daily vaccinations. Also, that's only percentage of how it's going, and these numbers are in millions. Also, we have vaccines. The type of vaccines we have AstraZeneca, Pfizer, and the Johnson and Moderna. So in the aim of this video is to actually explain the code itself. However, we got to understand the dataset or a part of the dataset in order to run the code. So going back to the code, so here we imported the important libraries as always, the NumPy, the pandas. So NumPy is basically algebra, linear algebra, and we have the pandas. We use it, for example, reading the file, and then we have the plot to plot, and then we have the Born is also a plotting uh, uh, um, library we can use to make it more accurate or more useful, more data input into it. So first thing, we retrieve or read the data set through this code, which is a banded to read CSV. So we want to make sure the code is running okay and the data is retrieved normally. So we use the .had method, and then it's just show the first. For example, here I chose 5, so from 0 to 4, that is 5 rows. So it's just want to make sure everything is imported okay. So in here we just get a head of information. So for example, here it says we're checking the nulls and we're checking the type of data. For example, that's object, that's a plot. If we had integer, it will say integer. So we just want to make sure what we are training for the next or for the upcoming um, algorithms. So here I'm grouping the data. So here exactly I chose then the United States. Well, as the data set has many countries, so I chose the United States because it had the most all the rows are filled in with information or numbers. So that way could be easier for us to understand and run analyzing or training and predicting a result. So here I use this code. I called a variable United States, and then I passed the data set and I used loc as location dataset dot the country was set it to United States. So it's just saying go find the United States and then group them by which is from the country attribute. So here is just the head again. I just want to make sure everything is working fine again, and then here we just have the sum of the nulls value. So if we do have nulls value, so here because I run it through the United States variable, it's just giving me 14 null, 15, but previously here it gave me more than that because that's all the information are in the data is being read and analyzed. But here I'm only choosing the United States. So here my focus is on the total vaccination, people vaccinated, people fully vaccinated, daily vaccination. Okay, it's not included, but people fully vaccinated and total and people vaccinated, people fully vaccinated, and the daily vaccination, also the row. So the target will be the vaccines. So the target, or let's say the dependent variable will be vaccines. Let's see how many people got the vaccines on the type. It's just according to the type of the vaccine. So here I'm just plotting the people vaccinated with the date. Like here we have 129 days. I have got it somewhere here. Yeah, it's 100 in 129 days. This much of people got vaccinated. So people vaccinated means only once. The people who got it once, or maybe got another one, but that's the first shot. Let's call it the first shot. So it shows like how with the days it's moving and getting up, and more people are getting vaccinated. So using this code, it plotted this one. Okay, so here I just got I couldn't fix this issue, so I couldn't actually separate them. I couldn't find a solution for that. But anyway, so this one is for the fully vaccinated people and with the dates. So here it shows in millions actually. Here in millions, for example, this one 4 million, and here 12 million. And here it shows people fully vaccinated. For example, here around 800. So the second row, people, like for example, that's the first one who got the vaccinated, and that's why we have empty spot here, because people waited to get the second shot. Okay, so here it shows the daily vaccinations, how the daily vaccination is going. So some people, for example, they started coming and then less, and then people started to have a second vaccination. So this attributes my get inaccurate to the data set, because people could be repeated twice in the people vaccinated. So that might be an issue. Okay, here, as I said, we showed the number of the days. Um, so here it's the total vaccination so far. So that's the total vaccination so far. So if we put the numbers together, it should get around 700 million shots. 700 million shots. Uh, um, Not the people only. So it's just recording the shots. Okay, so because some people got twice, so that's why the number might be doubled. So here it's, well, the number is not accurate as I explained, because some people got twice, and some people maybe registered twice in somewhere because of the second shot. So it just did a little bit of unclear numbers. So here I had an idea of running the trained data on number of algorithms. So I will explain that later when I keep going. So here I named a variable called data2. So this variable is coming from the United States variable that I did previously. So what I'm doing is I'm only bringing the data that relate to the United States to the training to do training. Okay, so here I'm just printing the length, and here the shape, and then the describe, we will see it later, and then the group by vaccines, I want to see the size. Okay, so yeah, so here I'm checking about the null values. So as we checked before, we had null values, and the total vaccination, people vaccinated, people fully vaccinated, all those attributes had the null values. So what it's doing here is replacing them with mean and this is one thing. The other thing is some algorithms, excuse me, um, don't take integers. So that's, well, for example, let's say the attribute is it doesn't have a null value, but since it's integer, sometimes the algorithm does not take it. So that's why it's good to have a mean. So basically it's just adding dot zero if there is a number. If there is no number, it will just add a mean to it. So yeah, as I said, this is just replacing the null value. So here I got it a little bit different, because here what it's doing, it's replacing with uh, nan, for example, none, and then give it, okay, if it's none, fill none. So if it's none, just fill it. So here it's writing none, and here it's just filling it. If it's none, it replaces it with the mean. Okay, so here, as we did on the course, so we use the array, and then we pass the values to it, and then we pick which attributes we want to include. So here, starting, for example, 0, 1, 2, that's the third attribute, and the fourth attribute was, which is 3 here on the array, it was the total vaccinations. And here we're just comparing it, or let's say we are training it with um, the number 12, which is the vaccines. So here we use the split. So here we use the test split. Yeah, train test split library, and then we split it, and then we did have the size of the test as 20. It could be 30, it could be 40, it depends. So here are the models that I am using. So what I'm doing here is I am comparing all the models, and I will pick out the best value that it has. um, so here it's just I'm having array named result, put everything in it, and then in the names, and then just put everything on it as array, take it as array, and then the for loop is just to run and then loop through the algorithms, those algorithms. So here we are printing them, and here I'm plotting it. So it's just algorithm comparison. So I'm just comparing it. So here what we got, so that's the number of days, that's the array, or let's say the input size 129 over 15, and then that's the scribe is just giving us some information, account of the total vaccination, the mean, standard, minimum 25, and then the max, and it's doing this for each attribute. Okay, so here, as I said, I'm just getting the size of the vaccine, so it's just like doing it like, for example, Johnson and Johnson, there are 19 places vaccinated people with, and Moderna there is 70 places, um, or 70 days people were getting Moderna, and here the Pfizer are almost 40 days. Yeah, I know the data set is a little bit confusing. Okay, so here we have the model algorithm comparison. Uh, so that's the comparing. So the best one was the KNN, the K neighbor nearest neighbor, and it got 92. That's what I'm going to use. It's just showing like a really quick show. It's just saying like at least 0.8, and then the value, sorry, 0.5, and then the value is 9.2. So it's just showing that. So here I'm using the k neighbors classification, or classifier, let's say, and then we fit the data with through the train test split, and then we do the prediction. So here I'm using the accuracy score, which is this library up here. It's just get some information just like that. And then we have the confusion matrix. This is what it is. And then we have the classification report as it is. Okay, so here it's obviously showing 92 out of 26. Yeah. So here I'm visualizing the actual values and the predicted values. So the blue one is representing the actual values, and the predicted one is the orange one. So they are moving almost closely to each other. So that's why it's 92%. So from this graph, honestly, is it still can't say if it's accurate, and it's hard to read it. So that's why I came up with the idea of trying the k-means, which means clustering. So we didn't have um, a known attribute, and then, or let's say a dependent value. So I use the k-means to do the clustering and then pick out itself. So here I did it again with the array only 3 to 7, and then I did the range. So that's the elbow basically. So that's the elbow. It will pick out the best number of cluster that we could have. So that's when we print out the elbow. So here it showed almost 4. So it chose 4 because here where it changed. Well, I think it's 3, but well, I chose 4. I know I did that honestly, but it should be 3. Yeah, it should be 3. But anyway, yeah, I did it. So I chose 4, and then I did it as the in cluster, and then I passed the data to it to predict it. So it's just from there. Um, so after running the prediction, that's what we got. So it's 4 groups. So it's still a little bit not accurate and confusing. So this one is just showing the vaccination in the United States, like as a whole. The number of vaccinations and the brand was vaccinated, so it should be 3 anyway. um, yeah, so this is the end of the video, going over a little bit overview of the project and as well as the codes. um, yeah, that's it. Hope you guys enjoy it, and thank you for watching. Again, the group number is 10, Ahmed Al-Anazi, and my partner is Rasheed Al-Hazmi. Thank you for watching again.